Dear learners, we'll do a bolted design connection of a truss joint. The problem is given us a joint of a truss connection has the D types of angles and loads as shown in figure. So the next slide we can see the members and the amount of load transferred through the members. The bolts are used for all the connections are M16 grade 4.6 and gusset plate is of M3 410 grade. We need all these details, type of the gusset plate and size of the bolt we need and the grade of the bolt. So with this details we can design this connection. We can see the connection of a truss member. Main members, two diagonal members are connected with the two horizontal members. So the diagonal members are inclined at an angle of 45 degrees and it carries some 180 kilonewtons and this horizontal members carrying two angle sections, it's carrying 160 and this side the amount of force transferred is 300 kilonewtons. So let us go to the solution. So by seeing this arrangement we can understand all the members are at double shear. So let us calculate the strength of the bolt in double shear. Strength of M16 bolt of grade 4.6. So all the bolts are in double shear. We have to calculate the shear strength of double shear strength of the bolt. So the formula given in IS 800 FD VDFD equal to FU by gamma MB root 3 bracket open NNALB plus NSAS. So let us substitute the values. So we know very well ultimate strength of the bolts are 400 and the corresponding factor of safety is 1.25 into root 3 bracket open. Number of planes in the shaft portion 1 and this is the reduction 0.78 for the threaded portion and the diameter of the bolt is 16 pi d square by 4 plus number of the shear area in the solid portion. So that is 1 into without any deduction and substituting the area of the bolt. So simplifying this calculation, I can get 66.08 kilonewtons. So this is the double shear strength of the bolt. Next I have to identify the strength of the bolt in bearing. So again, with reference to the IS 800 formula, we can find the strength of the bolt in bearing. So for that, you calculate the nominal bearing strength and divide it by the factor of safety, you can get the strength of the bolt in bearing. So what is the nominal bearing strength formula? 2.5 formula. 2.5 kb dt fu by gamma m1. So we need to find kb separately. kb is the smaller of E by 3 d naught, P by 3 d naught minus 0.25. So we have to find all these four criteria and take the smallest one. And fourth criteria is third criteria FUB by FU. This is the ultimate tensile strength of the bolt by ultimate tensile strength of the plate. And fourth criteria is number 1. So we have to find all these four criteria. So we have to think what is the edge distance to be provided, what is the pitch to be provided, and what is the diameter for bolt hole diameter, everything. So let us keep the pitch is 50 mm. How I kept the pitch 50 mm? I have to choose minimum pitch 2.5 D. So what is 2.5 D? 2.5 into 16, 40 mm. So let me keep the pitch as 50 mm above the minimum. So let me keep the pitch as 50 mm. Next edge distance should be 1.5 times D. So 1.5 times diameter of the bolt hole. That is 18 mm. Bolt hole is always 2 mm excess of the bolt diameter. So this is 27 mm. Let me keep it as 30 mm. So pitch is taken as 50 mm, edge distance is 30 mm. So with this idea I can calculate the KB. So now we will come back to the KB calculation. E by 3D0 minus 0.25. So E is 30 plus. It is KB is E by 3D0. So let me calculate E 3D0 80. So this value is 0.56. Next I am calculating P by 3D0 minus 0.25. So P 50 by 3D0 80 minus 0.25, 0.676, and 3 FUB by FU. So that is 400 divided by 410. So that is 0.97. And fourth numeral value is 1. So let us check what is the minimum value. So among these 4 values, this is the least one. So let me decide KB is equal to KB equal to 0.56. So now we can find the design bearing strength. VDPB equal to 2.5 KB DT. D is 16 mm. T thickness of gusset plate 12 mm. If it is not given, we can assume. And the ultimate tensile strength of the plate 400. And the corresponding factor of safety 1.25 into 1000. So this value is 75.26. So what do you understand by this? So at 66 kilonewton the bolt fails by bearing, shear. At 75.26 kilonewton the bolt fails by bearing. So let us take, by considering this we can take the least, therefore least of shear strength and bearing strength. So let me take 66.08 kilonewton as the volt value. Then we can decide how many number of bolts are required for connecting each member. Number of bolts required. So for example, if the load acting on the member, bolts required for 300 kilonewton member. (300 divided by 60.66.88) 4.53. So approximately 5 volts. Similarly, the number of bolts required for 160 kilonewton force. 160 divided by 66.08 kilonewton. 3 bolts. 3. bolts required for 180 kilonewtons. 3 bolts. So we have decided the number of bolts required for transmitting this much force. For 300 kilonewton we need 5 bolts. For transmitting 160 kilonewton 3 bolts. And for transmitting 180 kilonewton force 3 bolts. So with this we can we can close the problem and we can draw the detailing diagram. Let me draw the detailing diagram. So this is the gusset plate and it is attached with the angle. So let me take this angle. So it is attached with one more angle. So let us provide the bolts. So we need 3 bolts for connecting 160 kilonewton. So for connecting 300 kilonewton we need 5 bolts. And for connecting gusset plate and 180 kilonewton again we need 3 bolts. And this is also 180 kilonewton, we need 3 bolts. So this is the final detailing diagram of the. In this way we can design the truss connection. The thing is we need bolt value. So if you know the bolt details we can find the bolt value. With this we can find the number of bolts required. So let us conclude this gusset plate thickness is also 12 mm. And thickness of all the angles are already given 6. So this is the connection details of the truss joint. Thank you.